Morning students. Last class we have started the important chapter because every now and then we are using lines and angles. Whichever geometry you are using lines and angles, circle, quadrilateral, triangle, we are using. So lines and angles. And we have what we have studied in the last class? Different angle measurement. Or starting from the zero till the complete angle. Starting from the zero till the complete angle. Can you recollect what I have given? I have given first 0 degree. Then I have given greater than 0 degree. Suppose angle is A less than 90 degree. Then I have given A equal to 90 degree. Then I have given A greater than 90 degree, less than 180 degree. Then I have given A equal to 180 degree. Then I have given A greater than 180 degree, less than how much? Less than 360 degree. And last, what is that? A equal to 360 degree. So A equal to 360 degree and this one is 0 degree. So see, one thing you see, 0 degree, then equity angle, then right angle, then obtuse angle, then straight angle, then reflex angle, then complete angle. How many angle? 0 degree, so there is no special name because no deflection of the ray. Then equiangle, greater than 0 degree, less than 90 degree. If equal to 90 degree, then right angle. What is the symbol to represent right angle? This is the symbol to represent, that is perpendicular. Then we have seen the obtuse angle. Okay, obtuse angle, what is the measure? Greater than 90 degree, less than 180 degree. Then we have seen straight angle. Straight angle. See, this is the straight angle. This is the two rays. And if this is my head definitely it is equal to both the sides. So this is, if you consider, this is one point, this is another point, this is another point, then this point represent 180 degree. Now, if it is greater than 180 degree, less than 360 degree, greater than 180 degree, less than 360 degree, then what it will be that? It will be reflex angle. And if it is equal to 360 degree, that is known as complete angle. These are the angles named by virtue of their measurement. Now, with that measurement, you will get a triangle. This, if all the angles of a triangle falls under this, then this triangle, that triangle is known as, what is that? Equiangle triangle. If one angle of a triangle falls under this, then what is that? Right angle triangle. And if one angle of a triangle is greater than 90 degree but less than 180 degree, then what is that? Obtuse angle triangle. So see, with this measurement we got 3 different triangles as well. And this is obviously a straight angle, so there will be no triangle at all. This is reflex angle, no triangle at all. And this one related to what? Can you tell me? Can you recall that angle A equal to 360 degree represent which one? It is the value of circle. Circle measurement is 360 degree, and that is the reason it is known as complete angle. It is very much related in our day-to-day life, all these measurement. How? Whenever you watch, you see your watch, you see your wall clock, you will find all these different measurements. The moment it will be 360 complete, that means either 1 hour complete, or 1 minute complete, or 1 second complete. 1 minute, 1 hour, or what happened? One complete rotation of the second hour, second hand, it will give 1 minute. So 1 minute, 60 minutes equal to 1 hour, 60 seconds equal to 1 minute. So that is very much part and parcel of our life. Okay, you cannot give up this one. So these are the things we have studied. Now today what we are going to do. And remember one thing, this method, it is long time objective as well as short time objective. Short time objective means you have to use this one to solve your exercise questions. And in long term, that whenever, if you are an engineer, if you want to construct a bridge, if you want to construct some decoration in a building, then you have to remember at what angle, how much deviation will be there. So that is the long-term objective. And short-term objective is that by using of these, because if you don't know straight line, straight angle, you cannot solve. Clear? So these are the things. So let me today discuss some other important points related to angle. That is, now we got all these different measurement of angles. Now let me see that angles name, different angles. Suppose you got already. I'll just discuss. I'll not take much time with this. Suppose here, can you identify how many angles are there? How many angles are there? Whether it is 1 angle, 2 angle, 3 angle. Basically, here are 3 angles. Basically, here it is 3 angle. How it is 3 angle? Angle ABC, angle ABC. This is 1 angle. Angle ABD. This is another angle. Angle DBC. This is another angle. But here, I'm not going to say how many angles. I want to say what is the relation between these 2 angles. See, these are the 3 fingers. These are the 3 fingers. These are another finger. What is the relation? Whether these 3 are not related to each other? They are related to each other. How? They have a common hand. Same way, these 2 angles has a common vertex. Has a common vertex. So if two angles have a common vertex and a common arm, then what is that? They are known as adjacent angle. They are known as adjacent angle. Okay? Now adjacent angle, you can find something else as well. In the sum of 2 angles, if 90 degree, then it will be right angle, complementary angle. That will be little bit different. Complementary angle, you cannot say here. Complementary angle and this one, little bit difference. What is that difference? Here both the angle with a common vertex. But in complementary angle, both the angle need not be or not to be a common vertex. Sum of measures of 2 angles, if it is 90 degree, then they are known as complementary. Similarly, if 2 angles makes 180 degree. Suppose this is D, A, B, C. And another one you see, X, Y, Z, P, Q, R. When you see these, the measure of these 2 angles is 180 degree. And when, if I write angle XYZ plus angle PQR equal to 180 degree, then whether here also angle ABD plus angle DBC equal to 180 degree. Can you tell me what is the difference? Difference is that these two angles form a linear pair. If sum of two adjacent angles is 180 degree, there they are known as linear pair. They are said to form a linear pair. And on the other side, if sum of measures of two angles is equal to 180 degree, they are known as supplementary angle. Just like this one. See, this one, these two is not the complementary angle. They are adjacent angle. If complementary angle, then it should be like this. It should be like this. This is one angle, angle A, B, D, and this will be another angle, D, B, C. And these two, if we make one 90 degree, then it will be complementary. Here it is adjacent angle. Here it is adjacent angle. So if sum of measures of two adjacent angles is equal to 180 degree, then they are said to be a linear pair. And if sum of measures of two angles is equal to 180 degree, but not a common vertex, then they are said to be supplementary angle. So complementary angle, supplementary angle. So complementary angle, supplementary angle we are writing this way. Then complementary angle, how can you write? Angle A, B, D plus, that means I just want to replace this one. So angle D. So in place of D, I'll put it, suppose E, and this is F. So angle EFC equal to 90 degree. This is complementary, supplementary, this is complementary. 90 degree is complementary angle and 180 degree is supplementary. Okay, so today we got another 4 different angles. What are these? First we got adjacent angle, second we got complementary angle, next we got linear pair, and fourth we got supplementary. Clear? And then I'll prove one theorem. If two rays intersect each other, just I will show you. If two rays intersect each other, see, this is the two rays intersect each other. What happened? How many angles? Can you identify how many angles? Like, just like the previous one. Here are actually 4 angles. 1, 2, 3, 4. How many angles? 1. This is 1. This is 2. This is 3. And this is 4. 4 angles. So whenever two line or two ray intersect each other, then they form 4 angles. Can you recollect that where did you get these 4 angles previous to this chapter? Before I wrap this thing, I'll give you the time. And then let you think, and then I'll give my answer. And by this time, I'll clean the board. Okay, my work is over. By the time, I think I've already got the answer. Answer is linear equation in 2 variables and coordinate geometry. Graph. Yes or not? That a plane divided into 4 parts. Each part is known as quadrant. Now here, that other one. There it was, all the 4 angles should be 90 degree. Here need not be 90 degree. So let's see. See, A, B, C, D, and this is the point of intersection. AB and CD are 2 rays intersect each other at O. How many angles? 1, 2, 3, 4. 4 angles form. Same as in your graph. But only difference is that it may not be 90 degrees. It may be 90 degrees, no problem, but not necessarily 90 degrees. It may be other measure as well. Now what we have to do with these ones? Whether there is any application? Yes, obviously there is an application, and especially in your circle chapter. Vertically opposite angles are equal. That means angle 1 should be equal to angle 3 and angle 2 should be equal to angle 4. See, vertically opposite. See, this one and this one. Both are vertical angle, vertically opposite. If I rotate this one in clockwise or anti-clockwise direction, then 2 and 4 will be also vertical. So vertically opposite angles are equal, and it is given in your book, page number 94, theorem number 6.1. The two lines intersect each other, then the vertically opposite angles are equal. Vertically opposite angles are equal. Now, last time I have given some marking. Now, this marking will be helpful for me. Now, first of all, you write, let AB and CD, remember theorem number 6.1, page number 94. Page number 94, theorem number 6.1. Important, remember, if theorem will not come, its application is very, very important. Okay? So let AB and CD be two lines. Intersect each other at O. Intersect each other at O. To prove angle 1 equal to angle 3 and angle 2 equal to angle 4. Now I have written here by number. It is not necessary that you have to write by number. You can write angle AOC equal to angle BOD and angle AOD equal to angle COB. You can write it down. No problem. Absolutely no problem. Okay. Now, in geometry, if you have studied in class 9 that quadrilateral chapter, that theorems, okay, parallelogram, rectangle, square, rhombus, then you have seen when you are going to prove the geometrical theorem, then there are maximum 4 parts. Maximum 4 parts. First part is the introduction I have given. First part is the introduction. Second part, what you are going to prove. This is the second part. Third part is construction, if it is needed for proving the theorem. But as of now, there is no construction. So construction part is optional. That is not compulsory for every time. It is optional. What is the compulsory? Introduction, what you are going to prove, and the main proof. These are the 3 things. This one is not mandatory. Clear? Okay. So then, you see proof. Now, see, angle 1 plus angle 2 equal to 180 degree. Why? What is the reason? Did I discuss? Since linear pair. What is that? Linear pair. Equation number 1. The next, angle 2 plus angle 3 equal to 180 degree. Once again, same. Equation number 2. My dear student, I have given here is a comma, but you don't give. You have to write it down. You will get the marks, I will not get the marks. I just want to save the time, nothing else. Okay. Then from 1 and 2, see both the equation is 180 degree, 180 degree. From 1 and 2. What will you get? Angle 1 plus angle 2 equal to angle 2 plus angle 3. So angle 2 is common, cancel. So it is angle 1 implies angle 1 equal to angle 3. That means, what is this? That means vertically opposite angles are equal. Now you may think, sir, you have written 2, but you have proved 1. Yes, similarly we can prove that angle 2 equal to angle 4. Similarly we can prove that angle 2 equal to angle 4. So with this, I will wind up for today, but before I go, I just want to tell you that what we have got. We have studied, first we have started with the previous one, then we have studied 4 angles. What are those? What are those? First is adjacent angle, complementary angle. Then, what is that? It was linear pair, then supplementary angle. And then, finally, we have proved that vertically opposite angles are equal. So, with this, I will wind up. My dear student, please practice this. Only one theorem given, so please practice it nicely. Thank you. Till that time.